when you see y is equal to 1 over x plus 2, it should come to your brain that this is a parent, or the parent function is y equal to 1 over x. And that the shape of that is a hyperbola, okay? Do you remember that shape? This assignment is to help you get familiarized and remember those shapes, okay? Those need to come to your brain rather quickly. They get used throughout this course and the next course that you take. So the question is, what kind of transformation exists? And I want to be clear that y equals 1 over x plus 2 is different than y equals 1 over x plus 2. You see, one of these plus 2's is on the inside, and one of them is on the outside. Is this plus 2 on the inside or outside? Inside. It is on the inside, so that's what a horizontal shift looks like in this situation. So is it going to move it right 2 or left 2? It's going to move it left 2 units, okay? So what I will do is I'll take this vertical asymptote, and I will move it left 2 units, okay? And I have my horizontal asymptote. Okay? So notice that everything just shifts to the left, and then you have this shape and that shape. Not too bad, huh? Okay, let's try some more. Next one, a lot of people see this, they get confused. Well, this is the same thing as, so the parent function is y is equal to the cubed root of x, or x to the 1/3 power. So those are the same things, cubed root of x and x to the 1/3 power. Do you remember what the square root function looks like? Yeah, so Evie sees that square root function looks like that. Do you remember what the cubed root one looks like? Why? Why?
Because it can't be. Yeah.
Square root can't be negative, but a cube root can. So therefore, the cube root function, the parent function, looks like this. Okay? That's the cube root function. And so the transformation, the -3 is on the inside, so it's going to move it 3 units to the right. And so there we have our cube root shape. The next one, notice how we have another x in the denominator. The mistake has been made by many students as they're going through this part of their assignment that they think of y is equal to x squared. That would be if the x squared is in the numerator. This is in the denominator. So the parent function is y is equal to 1 over x squared. So it's going to look similar to the first one, but the difference is because it's being squared, it makes everything positive, so it's going to be above the x-axis. So the parent function looks like this. And you don't have to draw the parent function. You don't have the ability to use colored pencil all the time, stuff like that. I get it. Maybe you want to sketch it really light. That's up to you. But let's look at the transformations. Number one, you have a -3, which is going to move it 3 units to the right. So I know that. There's no vertical shift, but then you have this -2 on top. Sometimes you have to learn to ignore numbers. The 2 is on the outside. It does what we call a vertical stretch. We're going to learn more about that tomorrow, but it doesn't change the general location of the graph. But this negative does change the location. Notice how the negative is on the outside, and that's going to create a vertical flip. So instead of both being above, both are going to be below the x-axis. So you get that shape. Okay, I'd like you to try the next one on your own. This should be a little bit of review, a little bit trickier problem, but y equals the square root of 4 minus x plus 1. See if you can do that one on your own. Okay, that's what the square root function looks like. Notice that if you factor out the negative, okay, you've got an x minus 4 here. That tells you that it shifted to the right 4 units. The plus 1 is shifted up 1 unit. And then notice the negative is on the inside, so it creates a horizontal reflection. So that's the shape that you're looking at. That's the shape you're looking at. Okay, so if I'm taking this test, because I was what's the word? Obsessive. I was obsessive about this in mathematics. I'm going to check my answer. You're like, well, how can you check your answer? By the way, you can't plug this into the graphing calculator on the test and press graph and check your answer. So on the test, you can use this all you want, but you can't press the graph button. I can't have you guys just sketch a graph so these are copy them down. Everybody get that right? So let's say you want to check it. Here's how I check it. I'm like, oh, the graph shouldn't have a value at 5. So I tried plugging in 5. What's 4 minus 5? And the square root of negative 1? Imaginary, right? So I'm like, okay, good. It doesn't go over to 5. And then it looks like if I plug in 3, I should get out a positive value. Let's try it. I'll plug in 3. 4 minus 3 is 1. Square root is 1 plus 1 is 2. Hey, what do you know? Like that's a good indication it's headed in the right direction, isn't it? So you have ways to try to check and verify your graphs. Okay, next one. Looks really crazy. It's not too crazy. We have a negative x minus 2 to the 5th power, and then it's a plus 4. So this problem is kind of helping you understand that you can sometimes rewrite expressions so they look a little bit easier to graph. A 5th power looks the same basically as a cubed power. So looks something like that. That's our parent function shape. Okay? And so notice we have 3 transformations. We are going to be to the right 2. We're going to be up 4. And we're going to have a vertical flip. So I'm going to move right 2 and up 4. So that's going to take that spot that was at 0, 0, move it there. And instead of starting down and finishing up, it's going to start up and finish down. Try that next one on your own. Try that next one on your own. Hi.
Hi. Could I borrow Ty and Vivian really quick?
I thought you wanted a double dose of mathematics.
I wish.
Yeah, go ahead, take it. Ty's the taller one.
Okay.
Did you get it? Any questions on that? Okay, we're going to do 5 more problems together. I'm going to give you guys time to work. This one is also a reciprocal function. Look at it looks different because I have a 5th power. So the parent function is 1 over x to the 5th. So notice that I've increased the degree here, and that's to help you understand that if it's an even power, they're both above the x-axis. Where if it's an odd power, they are in opposite quadrants. You see what I'm saying? So even though it's 1 over x to the 5th, it's the same as 1 over x cubed or 1 over x. It's going to have that same shape because it's an odd power. That's what we want you to kind of understand is how an odd has an impact compared to an even. So I know that the parent function has this type of shape. And what's the transformation that's going to happen? We got 2 of them. 2 transformations.
3 to the right and it's flipped.
3 to the right and a vertical flip. So instead of being the bottom and top, it's going to be the top and the bottom. Okay. Fourth root looks kind of tricky, but notice fourth root is going to be the same as a square root. Fourth root's the same as a square root for shape, basically. Now, in order to figure out the transformation, when I think of a transformation, I can't have a number in front of the x. So I have the fourth root of 2 times x plus 3. And when I factor that 2 out, now it's easy for me to see that the x plus 3 creates a horizontal shift to the left 3 units. Never mind the 2. Ignore the 2. Those multipliers we're going to talk about tomorrow. Just go left 3 units and draw from there. Hi. Was it a race? Because he won if it was.
Yeah.
All right. Should go for track, Tyler. What do you think, Alex? Triple jumper right there?
Yeah.
High jumper?
I was thinking pole vault.
Probably pole vaulter. Read my mind. All right. Next one. Y is equal to x to the 1/3 power. This is a cubed root function. We've already talked about it before. Has this kind of gone into your memory? I hope it has. Parent function looks like that. But this transformation has an x plus 2 on the inside, which means we move it to the left 2. And the negative on the outside means it's flipped upside down. So I'm going to have that. All right. 2 more together. I'm going to circle one of these, and I want you to try it on your own. I want you to do this one right there. That one. Go ahead. Give it a shot. Try something trying.
Dude. Holy crap, man.
All right, pause where you're at. When I get to the test or the study guide, I'll find that people can do all the green ones that I've circled. But then they get to this one and say, Mr. Gates, I can't figure that one out. And what shape does that make? It's a line with a y-intercept of -3 and a slope of 2. Now, you're saying to yourself, well, I didn't know we were supposed to do that. There comes a time where you can't be told what to do. You have to continue to recognize the shapes that we've done over and over and over again. That's all I want in that situation. Last one we do is this one right here. And this reads the negative x raised to the 2/3 power plus 4. And the parent function for x to the 2/3 power, let's just think about it. What happens when you square something? You make it positive. So this kind of looks like x to the 1/3, which looks like this, except when you square it, it's going to bring this part that's at the bottom, it's going to flip it up and make it positive. We did talk about this in our notes. We called this the bird function, if you remember. It looks like this. Okay? That's x to the 2/3. So negative x to the 2/3 plus 4, it goes up 4 and it's flipped upside down. And that's that. So there's 4 pages of this, 2 pages front and back. You got 17 minutes in class right now to continue to work on it. Answer keys posted online, it's also up there. True or false, you have a test on Friday.
False.
Absolutely false. You got a test next week. We'll make sure you get ready for that. And hopefully have a really good grade going into your MEA break. That's all I got for you.